Great, thank you. So I'm going to be talking about some of the content relating to weather and climate extremes in a changing climate, and that includes extremes globally, but also specifically for our Australian context. So I just have a figure up here taken from the World Meteorological Organization that shows just a sample of some of the extreme climate events that occurred back in 2018. And some of these event types throughout the world, including hurricanes or tropical cyclones or heatwave events, some of the climate extreme events that are covered in the content of the report. So there's been a significant number of advances in terms of the science since the next most recent IPCC reports. So the Working Group 1 report from AR5 and the SREX, the special report on extremes. So some of those advances that have gone into the AR6 report include really around extreme event attribution. So that's a really major development in the discipline of understanding extreme weather and climate events that has really emerged rapidly in that period since 2012, 2013. So by extreme event attribution, they're studies that are looking at trying to understand from a quantitative perspective what were the contributing factors in an extreme weather or climate events. So since that 2012-13 period, there's been a multitude of attribution studies, a very large number of studies that are now available for assessment. These are using multiple models rather than just one climate model, and a multitude of techniques. And they're also focused on a broader range of events. So within those earlier IPCC reports, the event attribution studies were really focused on some heavy rainfall, but predominantly around heat extremes. So in total, those extreme event attribution studies offer us new and stronger insights into links between particular extreme events and climate change. And again, they're expanded to focus on more complex climatological events such as droughts, tropical cyclones, or compound events. And I'll talk about that a little further now. So one of the other advances is the discussion and the literature around compound events. And I'll be talking about that later on in these slides. But there's also an expansion in this draft report around the overall treatment of and focus on extremes. So Chapter 11 covers extremes in detail, but there is the discussion of extremes throughout the report, and that's become quite an important focus. There's also differences in the methods, concepts, and frameworks that have been used in the literature since those 2012-13 reports I mentioned, and one of those is particularly around both transient future scenarios and also levels of global warming. And that's really what I have in these little comparison plots here that I've used with permission from Dr. Andrew King from the University of Melbourne. So in a typical analysis of future projections, we might look at how global warming is changing through time and then look at different scenarios. So here we have two lines indicating possible scenarios for the future across the 21st century. And then we might look at snapshots, decades, and compare projections for the 2030s versus end of century. But particularly following the 1.5 degree report, there's also now a lot of literature that's focused on levels of global warming. So instead of looking at transient scenarios changing through time, we're looking at climates at a fixed level of future warming. So for example, 1.5 versus 2 degrees, or higher levels of warming around 3 or 4. So there's a huge amount of new literature that's focused on this concept and framework rather than looking at transient simulations. So I just thought I'd give a little bit of background on extremes before I discuss extreme event types separately. So the definition of extreme events is in itself quite difficult to establish in any one way. So an event is an extreme if a value of a variable, for example, temperature or rainfall amount, exceeds or lies below a threshold. So we might have an extreme heavy rainfall event or an extreme dry rainfall or drought event. but which threshold? There's different ways that we can think of extremes from a scientific perspective. So there's also extremes related to the impacts. We can think about that in terms of the impacts of a drought. But in terms of the Working Group 1 climate system, physical climate perspective, we can think about changes in the frequency of an event for a given magnitude of extremes. So that might be, how often does a 30-degree day occur in Brisbane? Or we can think about changes in the magnitude of an event for a particular return period. So a focus on the frequency of an event. So what is the size of, what is the amount of rainfall we expect to occur as a 1 in 20 year event? So we've got a magnitude versus a frequency. So most of the extremes covered in literature and assessed are based on the ETCCDI indices derived from the expert group on climate change detection and indices. And I have a link there where we can see, I think there are now 22 indices that are part of that catalogue there. So I'll jump in and talk about the different extreme event types. So temperature extremes were discussed in AR5, that special report on extremes, and 1.5, so this is the 1.5 degree report, with increasing evidence. So globally, warmer and more frequent hot days and nights have been observed over most land areas, and that is also projected to continue into the 21st century. For Australia, the observations and projections of temperature extremes, which are largely, again, I'll flick back, measured according to these extreme indices, which I have examples of here in terms of a hot temperature index and a cold temperature index. So for Australia, the picture is much the same as globally, with warmer and or more frequent hot days and nights over most land areas observed and projected for the future, and again with great certainty. So I have indicated throughout these slides where in the table of contents of the Working Group 1 report these events are talked about in detail. So in section 11.3, there's global information on temperature extremes and Australian information also contained in the regional chapter, chapter 12. So if we move on to extreme rainfall, and again indicated where that information is contained in detail in the report. Globally, there is an increase in the frequency, intensity and or amount of heavy precipitation, but that is regionally variable, and we can see that when we focus on Australia. So I've highlighted here a review paper that was published last year in Wire's Climate Change on precipitation in Australia that provides a really good context for this regional variation in observations and projections for extreme rainfall. So for North Australia, there's been observed increases mainly over the north part of North Australia, and I have some of the ETCCDI indices highlighted here in terms of both frequency and percentile measurements. So that's for North Australia, an increase mainly over the northern part of Australia. But for Southern Australia, there is extreme precipitation projected to increase, but the agreement among climate models for that projection for the 21st century is low. So there is uncertainty in terms of that projection. So just to recap there, globally, we expect an increase in the frequency, intensity and or amount of heavy rainfall with higher levels of mean global warming, but that is regionally variable, and we can see that with these two different North and South Australia zones. Again, the picture for drought is regionally variable. So these drought is discussed in, again, chapter 11, chapter 12, our regional chapter, but also I'll draw your attention to chapter 8, which covers the water cycle. So that includes explanations of the physics of drought and changes in aridity and the processes behind that. So globally, literature indicates there are increases in the intensity and or duration of drought events observed, and increased probability of intense frequent droughts with future global warming. And that again is a global picture, but that is variable across regions. So that is most certain in areas such as parts of the US and the Mediterranean. But in Australia, we see a regionally and seasonally dependent picture of drought. So in terms of the observations, there's a decrease in the number, duration and intensity of droughts over northwest Australia. But in terms of future, literature indicates an increase in drought in spring over southern Australia and in winter and summer over the southwest Australia. So with drought, we can start to see a more complex picture of observed and projected changes compared to temperatures, for example, where the region, the metric analysed and the season is really important for getting a picture of what's going on. And we really have to be looking at much smaller regions to get an understanding. And I just have highlighted here from a paper under review, consecutive dry days on an annual timescale, where we can start to see that there are some locations where the trend is towards a greater number of days per year, and some places where there are fewer. Again, with tropical cyclones and extratropical cyclones, these are covered in, again, Chapter 11 and Chapter 12 in the greatest level of detail. But again, we have to be thinking about what measures we are looking at to try and understand these extreme events. So the effects or impacts of tropical cyclones, as I note here, depend on both the intensity, the size, the track, and the translation speed. So there's lots of sort of ways that we can measure and understand cyclones that affect their impact. So if we're looking at observations of cyclones over the historical period and also the future projections, we really have to be thinking about various measures. So globally, there's a projected increase in the rain rates associated with tropical cyclones by 11%, and an increase in the proportion of cyclones that reach the strongest category, so Cat 4 and Cat 5 levels. There's also a projected extension of seasons and an intensification of the precipitation associated with severe convective storms. But Australia, the picture is a little more complicated, and in some places there is a trend has not yet been observed in the proportion of intense tropical cyclones, which is largely related to where they're tracking. So they may in general decrease in number throughout our region. And again, there's a lot of uncertainties around extratropical cyclones with very small changes or decreases in winter in South Australia observed. Sorry, Southern Australia, not South Australia, Southern Australia. So I mentioned that compound extremes were now covered in a lot more detail. So these were mentioned in SREX, and a definition was provided: 2 or more extreme events occurring simultaneously, combinations of extreme events that amplify the impact, and the co-occurrence. So in particular, in Chapter 11, there's discussion of the co-occurrent heat waves and droughts, humid heat waves, but also compound events where we have coastal zone flooding caused by heavy precipitation and storm surges. And I just have some information there about projections for various compound events that are increasing with higher frequency and or intensity. Marine heat waves is another event that was not discussed in previous reports. This is a cross-chapter box, so that's located in Chapter 9, but that is also shared with Chapter 11. These are heat waves occurring not on the land surface, but within the marine environment. There is a global increase in marine heat wave frequency, intensity and duration that has been observed and is projected. There's also discussion in the literature about the possibility of a permanent marine heatwave occurring in some locations and some ocean basins, but that the certainty around that is, and the likelihood is dependent on the location. There are many examples of prominent marine heatwave events from Australia, and I've just highlighted from this NESP website, the 2017-18 event. In terms of continuing with marine extremes, sea level rise and coastal extremes are not discussed in Chapter 11, but rather in Chapter 9 in detail and to some degree in Chapter 12. Globally, an increase in high tide flooding and extreme wave heights is discussed, with the strongest increases in the Southern Ocean. Projections are really focused around frequency amplification factors. So the differences among future scenarios increases over time, which can lead to very large increases in the frequencies which thresholds are exceeded. So there's further detail and information provided for you there. For Australia, there is an increase in the occurrence of historically rare extreme sea level heights, with more frequent events expected around all of our region by 2100. There's also been some identified gaps in terms of understanding and literature. In particular, a lot of literature is focused on the differences between 1.5 and 2 degrees of warming, with little focused on higher levels of warming. There's very little literature to date on high impact, low probability events or tipping points. Small scale extremes are also not covered in much detail. So for example, hailstorms. And there are remaining difficulties in terms of understanding extremes in some locations due to observational gaps. So we know that the network of observations is variable, with some places well covered and others there are spatial gaps, but there are also temporal gaps, with some sites providing longer and more consistent observations than others. So I'll leave you with my contact details. I have my email, my work phone, although that's increasingly less useful with our remote working arrangements, and also my Twitter handle, and I'd be very happy for people to follow up and direct any specific questions to me. Thank you.